Right, so in this question here, a couple of things to note, right? So first off, it's a negative function there. So second thing would be, can we simplify this thing at all? So this is already the most simplified form. If we have something that's already factored in the top and bottom, leave it, right? So that's the best case that we can have when we're trying to identify key features, right? Don't like expand the x plus 4 squared out. That would be stupid. You'd be giving yourself more work. You would do that just to undo it eventually, right? So this is actually going to have a couple of domain restrictions. Right, so we're going to have a domain restriction when the x minus 1 is 0 and when the x plus 4 squared is equal to 0. Right, so x minus 1 equals 0. Obviously, when x is equal to 1, x plus 4 squared equals 0. Notice that if you were unsure about this, you could square root both sides, and it would just turn into x plus 4 is equal to 0. Right, so x would equal -4. Right, so in a sense, it doesn't matter what the power is here, whether it's a 2 or 3 or like a 7/3, right? So just plugging in -4 there would always make the 0 raised to some power, right? So for whatever that's worth, like you don't have to do like square roots. All right, so then in terms of simplifying the function, well, we can't simplify the function. Nothing in the top and the bottom actually cancels. So we have this function that's negative x squared over x minus 1 times x plus 4 whole thing squared. All right, so then in here, we can then start to find some, we can then start to find some values. So in terms of in terms of vertical asymptotes, notice that since nothing canceled out of our function, then we're not going to have any holes here. So we have none. So both of our domain restrictions, x is -4 and x is equal to 1, those would be vertical asymptotes. If we want to find the degree of the top and the degree of the bottom, I have an x squared in the top. Right, so the degree of my top is 2. The degree of my bottom is going to be, I have x minus 1 to the first power, x plus 4 to the second power. First power plus second power is going to be third power. So it's 2 over 3. So this would be kind of a bottom-heavy fraction. So whenever the bottom dominates the top, it means that your horizontal asymptote is going to be y is equal to 0. In terms of x-intercepts occur whenever the numerator is equal to 0. X squared equals 0 whenever x is equal to 0. So 0, 0 is our x-intercept, which again would be our y-intercept here, right? Because when the origin is an x-intercept, it has to be a y-intercept as well. Or if you don't believe me, just plug in x is equal to 0, and you'll get 0 over -16, which is 0. All right, so then table of signs time. And so here's our table of signs. We have a vertical asymptote at -4. We have an x-intercept at 0. We have a vertical asymptote at 1. Right, so I'm just going to draw some vertical asymptotes in to remind me. And I'm going to throw in a 0 right here. Again, you don't have to do any of this stuff, but just to remember what we got. All right, so then here we can be a little smart here, because if we think about what happens if we look at values that are squared, anytime I square a negative number, like -5 squared, I'm going to get a positive number, right? It's going to be 25. Anytime I square a positive number, where it's obviously going to be positive as well, right? So here, since we can't plug in anything that makes the 0, my numerator of x squared is always going to be a positive number. If I plug in any number to x plus 4 squared besides -4, I'm squaring it, so it's always going to be a positive number. So notice that what we really have here is a negative, because the function was negative, times a positive, divided by another positive, and then this x minus 1. So realistically, we could treat this function in terms of a table of signs as just a negative number over x minus 1. It won't, there we go. It's having technical difficulties. Right, so a negative over x minus 1. And that can really simplify things, because if we plug in, say, any number less than -4, like say -5, -5 minus 1 is just going to be a negative number. Right, so we're going to get a negative over a negative. Two negatives means that we're going to get a positive value. If I plug in any number between negative 4 and 0, like, I don't know, -2. Right, so -2 minus 1 is also going to be a negative number. Right, so we're going to get a negative over negative again, get a positive. If I plug in anything between 0 and 1, my numerator is always negative now. If I plug in like a 1/2, right, so a half minus 1 is also going to be a negative number. Negative over negative gives us a positive. And then if I plug in any number greater than 1, like say 2, I'm going to get a negative number over 2 minus 1, which is going to be a positive number. Negative over positive gives us a negative. Right, so we're going to have this function that is positive, positive again, and then negative. Right, so, I mean, if you really care, the sketch is going to look like that. Boom. It's going to bounce. Boom. And then it's going to go kind of negative because it has to hit those horizontal asymptotes. Right, so where's the function less than 0? Only between 1 and infinity. Now, you want to be a little careful about how you write where it's greater than 0. You don't want to say negative infinity to 1, right? I would get what you'd mean, but you'd be wrong there because we're greater than 0 from negative infinity all the way up to negative 4, but we're not positive at negative 4, right? We have that vertical asymptote there. We're positive again between negative 4 and 0, but not at 0 because we're equal to 0 there. We're positive again from 0 to 1. Right, so this would be where we are positive. And again, this thing right here is not the same as saying negative 4 to 1 as your interval. Right, so just be careful about places where you end up being just identically equal to 0.